Hey everyone, welcome back to the channel where we break down maths questions the easy way. Last time we tackled questions involving sine graphs. Now let's switch to cosine and work our way through two exam style questions step by step. In this first question, we're given part of the graph y equals 3 cosine of 2x and we need the coordinates of the points R and S. First, let's remember standard cosine graph y equals cos x. This starts when x is equal to 0 and y is equal to 1. Here, the equation has a 3 in front of it. We're working with y equals 3 cos of 2x. This means that our x coordinates will all be half of what they are due to the 2 in front of the x, and our y coordinates will all be 3 times greater as there is a 3 in front of the equation. So our starting point will be 0, 3, because it starts at 0, 3 because our x coordinate halves, but 0 divided by 2 is still 0, and our y coordinates are all times by 3. And 1 times 3 is 3. The 2x visually means that the graph completes 2 full cycles between 0 and 360 degrees, so it's squashed. If you're a bit unsure about graph transformations, do check out another video I've made on it for a bit more clarification. Point R is where the curve crosses the x-axis for the first time. For cos 2x, this happens when x is equal to 45. And I'll show you how we got there. For a normal cos graph, the minimum point happens at 180 minus 1 and it's 0 at 90, 0. These are key facts that you need to know about cos graphs, which are helpful when solving the question. Now we're looking at point R, which is at 0, so we're considering the point 90, 0. But because our graph is not cos x, it's cos 2x, we must halve the x coordinate that gets us there. And so our point R is at 45, 0. Another way of thinking about this is we want 2x to equal 90. As where we originally had an x, we've got a 2x. This gives our x coordinate as 45. And our y coordinate is 3 times 0, which is 0. Next, point S is the lowest point of the cycle. This happens at 180 degrees for a normal cos graph, but we need cos of 2x. This time, we're solving 2x is equal to 180, which gives us x is equal to 90. This gives us the x coordinate of S. At this point, y is normally equal to minus 1. However, our new equation we're working with means we have to times all of our y values by 3. And so we get S occurs at the point 90 minus 3. And there we go. We've managed to solve both equations for an value for R and a value for S. If you want to think about it in terms of graph transformations, this is also a valid approach. And more information on graph transformations can be found in one of the other videos I've done. Our second question gives us the curve y equals cos x from 0 to 360 degrees. We need to solve cos x equals 0.75. And I'll take you through this question step by step. First, let's draw a line at 0.75, which is about here. This horizontal line is what we wish to solve for, and we want values of x that lie on this line. We need to see where this curve crosses the green line that I've drawn. And it's a good idea if you're in an exam to always draw a line at the value we wish to solve for. This happens twice between 0 and 360 degrees. From the graph, the first crossing is about x equals 42. So we've got our first x value. The second crossing is in the fourth bit. Cosine is positive there, and because of symmetry of cosine, we can do 360 minus 42 to get our second x value at about 318 degrees. Another way is to simply look at the graph and see what value it comes out to. We already know the y value as that was given to us in the question, 0.75. And so we can combine both facts to get our final answer. The solutions are 42, 0.75, as cos of 42 gives us 0.75, and 318 gives us 0.75 as well. And that's how we'd use a graph to solve an equation using the cosine function. The key takeaway from these two questions is to watch out for amplitude changes, horizontal stretches or compressions, and remember symmetry to find matching angles, as sometimes you're not given the full graph in the question. If this helps you feel more confident about cosine graphs, hit like, subscribe for more walkthroughs, and drop a comment below if there's a topic you'd like for me to cover next. You've got this. See you in the next video.